question number 3rd. Have question number. Are you trying it?
Yes, sir. So option C.
What option? C. Oh, you got option C.
I'm not sure, sir. Actually, I didn't get it.
So C. We have given a sinusoidal voltage which is Vt is equal to 100 sine 500 t applied across a pure inductor. So suppose we have inductive circuit of which the given voltage is applied. Therefore, is Vt. Inductance is given. So we have to find the current. So how we will calculate the current? Know that I is equal to d by we can directly calculate I is equal to I naught. First we will calculate I naught. So I naught is equal to V naught by XC, right? XL, sorry. V naught by XL. So how you will calculate I naught? What is V naught? V naught is 100, peak value of voltage, and XL we know that omega L. What is XL? Omega L. So XL is omega L. So 100 upon what is omega?
500.
Correct, 500. So we will get it as I naught is equal to 1 by 5. So this is the magnitude of
So 0.02.
oh sorry, yes. This is also omega and 0.02 means 2 into 100, right? So we'll get 1 by 5, 100 by 5. We'll get I naught as 10. Got it? So now we got the magnitude of current. Let us first, we can also do it like this, right? I is equal to V by R, right? V by XL. So V is given 100 sine 500t. Getting my point. So what is XL? XL we got 500 into 2 into 100, right?
Yes, sir.
Got it? So 100 and 100 will be cancelled out. So we get 10 sine 500. Understood? So C should be the answer. Got my point? You're getting it?
So why 500 into 2 by 100?
See, XL is omega L. Omega is
Yes, sir.
500 and L is 0.002.
Oh, okay, sir. Okay, sir. Got it.
Got it? But actually this is wrong. Most of us we do like that, but actually this is wrong. Why it is wrong? Can you tell me? The same kind of thing we did in the previous question also before in the last class. I have discussed with you, right? Like in this question. So getting my point. So generally we do that and the option will be given like that, but this is wrong. Why it is wrong? Can you tell me? Here we have, see, we know that current and voltage are not in phase in inductor. Getting my point? We have not added or subtracted phase. We have not considered phase here. This could have been true for resistor. This could we can write only I is equal to V by R. That is for resistor. Getting my point? Not in case of inductor and capacitor. We have to take phase in account also. You are getting what I am trying to say?
Yes, sir.
So this method would not work if this kind of calculation was so easy. Why we have studied alternating current and phase and phasor diagrams? We could have been directly applied Ohm's law, right? And we have calculated all the things, current, voltage, Why we have studied phasor diagrams and all. Getting my point? So you cannot do it like I is equal to V by R. You have to consider phase. So the correct method how we will do is it is. So first what we have to do is we can do it like this, but for magnitude of maximum current, we can calculate the magnitude of peak value of current by doing this. I naught is equal to V naught by X. Getting my point? So from here we can get I naught, but to get actual value of current, what we will do? We will apply this formula I naught sine 500t, that is omega t, and we know that in case of inductor, current leads or lags. In case of
Leads. Sorry,
inductor,
lag.
current lag. In case of capacitor, current leads. Getting my point? In case of capacitor, current leads. I told you in last C for capacitor, C for current. In capacitor, current leads. So obviously in inductor, current lag. So minus pi by 2. You have to write it. Got it? So
Yes.
you will get the value of current as like this. I is equal to, what is I naught? We got 10 sine 90 minus theta. This is actually, you can also write it like this. You can write it like this. I is equal to, you can take minus outside. So I naught sine, you can write it like this. 5 by 2 minus 500t. Got it? So minus,
Yes.
what is I naught? 10 sine 90 minus theta, cos theta. So cos 500t. So we'll get the value of current as I equal to minus 10 cos minus 10 cos 500. So which one is the answer? Actually, the correct answer is minus 10 cos 500t. Are you getting it?
Yes, sir.
So if you're getting something straightforward in alternating current, you just think it twice. Are you doing it correct? Getting my point? There is, everything is connected around phase in alternating current. You must be careful about phase. So this is the method to do all kind of like purely capacitive, purely inductive, or LCR or Ladder circuit. First, we will calculate peak value of current or voltage. Then we have to consider phase. Then we can write the expression for current and voltage. So we are done with we have done NEET questions also and JEE questions also for RMS values and for purely inductive and capacitive circuit. Now moving to circuits LR or LCR kind of circuit. So first, I think you are familiar with the formula in the last class. I think resonance circuit and all I have taught in the, I have taken one of the Azam sir class, right? If you remember, you were present there. So we have
Yes, sir.
studied about power factor, resonance, and all, right? So I think no need to
Yes.
write we can directly do the questions, right? We know the formula I is equal to B. We know the resonance and power factor R by Z. That we all are familiar, right? Do I need to write formula or should we do directly question? It will be better to do the questions, right? We know all the
Yes, sir.
formulas. All right. So directly we will jump to the questions based on that. Let us see question number 11. Is NEET 2020 question. So try this question. Question number 11. It's NEET 2020 question. You trying it?
Yes, sir.
See, it says it's NEET 2020 question asked recently. So it says a series LCR circuit is connected to an AC voltage source. So suppose we have and LCR circuit. When L is removed from the circuit, when inductor is removed, the phase difference between the current and voltage is 5N. So when we will remove inductor, circuit will be RC circuit, right? When we will remove inductor, the circuit will be RC circuit, only capacitor and resistance. So it says that the phase difference between current and voltage is pi by 3. So we know that cos phi is, in case of RC circuit, cos phi is R by Z, and which is, so from here we will get cos pi by 3. It is given pi by 3 is different, and R, what is Z? Z will be R square plus XC square, R square plus XC square. So from here we can write cos pi by 3 is 1 by 2, so that is R by R square plus XC square. Are you getting it? So this is equation 1. Now it says if in state C is removed from the circuit, the phase distance is again pi by 3 between current and voltage. So again, what will happen when C is removed? We will left with LR circuit. Are you getting it, Krishna?
Yes, sir. Yes, sir.
In that case, in case of LR circuit, what will happen? Cos phi will be equal to R upon R square plus XL square. Instead of XC, we will write XL square. Okay. And it is again given pi by 3, so we will get cos pi by 3 will be equal to R by R square plus XL square. That cos pi by 3 is 1 by 2. So this will be R by So now we have to find the power factor of this circuit. Hence we have to find power factor of the LCR circuit. And we know that power factor of LCR circuit, what is that? Power factor of LCR circuit cos phi is R by Z, means R by R square plus XL square plus XL minus XC whole square. This is the power factor. So if we know R, XL and XC, we can calculate XL minus XC square. So you see here what we can write. If you see equation 2, we can write it like from this equation 1, what we can write? We can write R square, 4R square. You see here, we will get 4r square. 4r square will be equal to r square plus xc square. So from here what we will get? We will get xc square is equal to 3r square, right? Got my point? So from here, again, if you see second equation also, you will get same thing. You will get xl also equal to 3r square. So from both the equation, what we will get? xl equal to xc. So this term will be equal to 0 and we will get r by r is 1. Got it? Without solving we can also say if you see equation 1 and 2 both are symmetric, so xl should be equal to xc. Are you getting it?
Yes, sir.
The correct answer should be B. Got it? So the length of the question is so long, it seems to be difficult, but actually it is not so difficult. We can,
Sir, it's actually supposed to be root 3, right? Because x is equal to root 3 r square. Root
yeah,
3.
so x is root 3r, but actually that is our not concern. Getting my point. If we will get x equal to root 3r, that is okay. But we are only concerned with xl equal to xc. Here you will also get xl square is equal to 3r square. So xl will be equal to root 3r. But that is our concern is not the value. Our main concern is we will get x equal to xl. Main concern is that. What we are getting here doesn't matter because whatever is the value of xl and xc, both will cancel out here in this expression. So yes, xl will be equal to root 3r and xc will be also equal to root 3r. It means xl equal to xc. Therefore, power factor will be equal to 1. Got it?
Yes, sir.
Now see question number 12. Go through question number 12. See what question says. It says a circuit when connected to an AC source. Connected to an AC source.
So I think option B.
We got option B. So let us see. A circuit when connected to an AC source of 12 volt gives a current of 0.2 amp. Same circuit when connected to a DC source of 12 volt gives a current of 0.4 amp. Yeah, the circuit is. So the first is circuit when connected to an AC source of 12 volt gives current of 2 ampere. Same circuit when connected to a DC source. So So, when the circuit is connected, whatever be the circuit, suppose we have AC circuit, we don't know whether it is series LCR or something. So, when connected to a circuit, when connected to AC source, when it is connected to AC source, whatever be the circuit, we don't know that. So, when it is connected to AC source, gives a AC source of 12 volt, it gives a current of 0.2 amp. When it is connected to a DC source, this gives a current of the source of 12 volt, it gives a current of 0.4 amp. What does it mean? See, if source is converted to DC source, what will happen? Here omega is 0. Getting my point? For DC source, omega is 0. It means when omega, and it will obviously it have some omega not equal to 0. So when omega decreases, what happens? Current increases. What's my point? When omega decreases, current increases. So now suppose we have uh, I'm getting from last, suppose I'm getting series, I'm considering from option D. So suppose we have series LCR circuit. For the time being, assume that we have series LC circuit. So what will happen in LC circuit? We know that I is equal to suppose we take I naught is equal to V naught by Z something. So first we will see Z or Z value. So for series LC circuit, we know that Z equal to L square minus XC square. Means what will be Z? Z will be equal to omega square L square minus 1 by omega square C square. So when omega increases, this term will increase this term will increase and this term will decrease. So net what will happen to Z? Z will increase, right? So current, what will happen to current? Current should decrease. What my point? Got it?
Yes, sir.
When we consider LC circuit, so Z will be XL square minus XC square. XL is omega square minus 1 by omega C square. So when omega increases, Z will increase, therefore current should decrease. But here what we are seeing, here we are observing that there is, omega is decreasing, right? So we have to take a case of decrease in omega. Sorry. So first we will consider the case of decrease in omega. So when omega decreases, what will happen? When omega decreases, this term will, we have to think the same way. So when omega decreases, this term will decrease and this term will, omega is decreasing, so this term will omega is decreasing, so obviously this term will increase, right? Omega is decreasing. So first term is decreasing and the second term is increasing. So omega is decreasing. The second term will, first term is decreasing and second term is increasing. Hold it here. We will see the second option C. Now I am going to option C, then we will discuss LC. So let us go to series LC set. First, then we will go to, so let us see series RC circuit. So what happens in RC circuit? Z is equal to R square plus XC square. So what is that? R square plus XC 1 by omega square C square. So in the question omega is decreasing, it means this term will increase, it means Z will increase, so current should decrease, right? So C cannot be the answer. What my point? Understood? C cannot be the answer.
So can you explain that again?
Let us see. I am considering option C, series RC circuit. So in RC circuit, we know that impedance is R square plus XC square, and we know that XC is 1 by omega square C is 1 by omega C. So XC square will be omega square C square. Now we know that omega is decreasing. So when omega decreases, this term will increase, right? So
Yes,
Z
sir.
will increase, it means current should decrease. But according to the given situation, current is increasing, right? Current is increasing. So C cannot be the answer. Got my point?
Yes, sir.
Now again, we will see option. Let us see option A, series LC also. LC series. Option A. Here what is Z? Z is equal to R square plus L square XL minus XC square. XL minus XC square in case of series RC circuit. So again, the term XL minus XC comes in LCR in LC circuit also we got XL minus XC. We have to decide for the term XL minus XC square. What will happen to that? Then we can decide the value. So if you see XL minus XC is omega L minus 1 by omega C. So when omega decreases, obviously this term will decrease, this term will increase. I will take minus sign. What I will do it like this. Take minus common. So we will get 1 by omega C minus omega L. Now, this term is increasing, this term is decreasing. Got it? It means what will happen to this term? Obviously, this term will increase. Got my point? It means what will happen to Z? Z will increase.
Sir, but there is minus sign, right? Should actually decrease at XL minus XC.
So it will not affect because here we have a square in the term. Getting my point?
Oh, okay, sir.
We have a square in the term. So that is why I am taking minus common because it will not affect the square value. So whether it is common minus outside or inside. So what will happen? Obviously Z will increase. Means current will decrease. But in actual, in the given situation, current is increasing. So obviously E cannot be the answer. Got my point? Got it?
Sir, can you explain the last part again?
We have considered XL minus XC. XL is omega L minus 1 by omega C. I have taken minus outside so that you can understand it easily. So now 1 by omega C minus omega L. Now since omega is decreasing, so obviously this will increase, this term will decrease. What will happen? Net effect will be increase. Getting my point? Suppose this becomes first term increases and second minus term decreases, so obviously net effect will be increased. So here Z is increasing means current will decrease. But in our given situation, current is increasing, it means E cannot be answered. Got my point?
Yes, sir.
Similarly, now we can understand this. This will have this will be same case with the LC circuit, right? Here we also have the same term. Got it? So
Yes, sir.
E cannot be answer also. So the correct answer is B. We can also check the V. If we have like option B, we have LR circuit, right? In LR circuit, we know that the impedance is R square plus omega square L square. And in the given situation, omega is decreasing. Given situation, omega is decreasing. If omega decreases, system will decrease. It means Z will decrease. It means current will. Got it? Correct
Yes,
answer.
sir.
So it was NEET 2020 question. Not so easy. We have to decide very precisely. You can do
Sir,
it very
sir, can
quickly
we
also.
consider it? Sir, can we do it like this as well? Like, we can consider the DC source as the ideal one, and since the AC one is decreasing, um, we can just say that it the current of AC is decreasing than the ideal. So this happens in the case when phase of this happens in the case when in series LR circuit, right? When the phase is 90-degree less than the ideal, right? So
We know that in case of LR circuit, phase is lagging.
yes, sir, that's
So lagging phase doesn't affect magnitude. We know that phase is lagging. That is okay, but lagging phase can't decide magnitude. It can only we can get like variation in cos and sine, but the peak value of current will not be affected by phase.
so.
So
But here, the voltage is same, right?
the voltage is same. Uh, Voltage is same. That is okay, but you know, actually, if you go by that, that will not be correct. Correct method to discuss since here we are switching from AC to DC circuit. So it will not be a good idea to go by phase. If it could have been like both circuit could have been AC circuit, then we can see what is happening to the phase and all. But we are switching from AC to DC circuit, getting my point. So
Yes, sir.
the only way is to see the change in impedance of the circuit. If impedance is decreasing, obviously current will increase. So the best method is to consider impedance. If you will go by phase and all, you will get more complications. Right here, we know the answer is coming as LR circuit. It is easy to like analyze that, but when you are actually doing it, it will be difficult to decide by phase. Getting my point?
So can we say that a DC circuit is a circuit where the current and voltage are in the same phase?
In case of DC,
Yes, sir.
in case of DC circuit, obviously, we can say that the, actually the concept of phase is not in case of DC, but yeah, like we can assume that.
Yes, sir. By taking that, I think we can approach in this method, right?
No, but in case of series LCR circuit also, a situation comes. The case of resonance, current and voltage are in same phase. Getting my point?
Okay.
So
Yes,
how will you decide?
yes.
I think the thing is that now you can, what happens if you go by option elimination method, you can easily eliminate C. And if you can decide only one between A and D, both will have same situation, right? If you decide on D, A is automatically decided. So you will left with option B only. Getting my point?
Yes, sir.
Yeah, that is all right. So the NEET 2019 question. Now do question number 13. The NEET 2018 question. Are you trying?
Yes, sir.
So the question says an inductor of 20 millihenry, a capacitor of 100 microfarad capacitor, and a resistor 50 ohm are connected in series across the EMF test. I think we did this question, right? Same, there was a mistake, like there was T, so we have discussed it.
No, sir.
This question, that was another question. The power loss in this. How to find power loss? Power loss means average power. So P average, we know the formula. What is that? PRMS.
E naught by R2, E naught by root 2 into I naught by root 2 cos phi.
Yeah, VRMS, IRMS. So VRMS we know. IRMS we can calculate and cos phi. So VRMS is V naught by root 2. RMS will be I naught by root 2 cos phi. Not I naught by 2 cos phi. And now not by 2. What is I naught? I naught we know that V naught by Z cos phi. We will get V naught square by 2Z. What is cos phi? Cos phi we know that R by Z. So not square by 2 R by Z square. Now we have to calculate Z square. So what is Z square? Z square will be R square plus XC square minus XA.
Sir, how did you convert V naught I naught by 2 to V naught by 2 into V naught by 2?
Let us see. This you understand, right?
Yes.
So we have put I naught is equal to, this is not 2, this is V naught, I naught is equal to V naught by Z. Got
Okay,
it?
sir. Okay, sir. Got it.
So now we will calculate Z square. Z square we know that Z square is R square plus XL minus X whole square. So now we have to calculate XL and XC. What is XL? XL is omega. So omega is given in the question. What is that? T40, right? So 314. What is L? 20 millihenry into 10. Then we will calculate XC. So So here we can calculate that. I don't want to do calculation. I'm trying to understand with
So X is 31.84.
how much you got
So X is 31.84.
and how much Excel.
6.28.
So now we have to find Excel minus XC square. What's value in the I'm trying another way of displaying. Let us calculate this. Excel is 31.84. You're getting let's do one more calculation. I want to save. We are getting different values, right? I want to be less calculated. So how much value you got this one?
Sir, after squaring, I got 653.
You got 650. Six
0.6.
five three, right?
Yes, a 0.6.
So now we can calculate that. That's a lot of calculations. Not a square by 2, r by z square. Let's do it by the way. Now, we got z square as r square plus this. This we got 653. What is r square? R square is 50 square. It's 2500 plus 653 will get approximately equal to like 3153. Yes, 3153. So we will get it. Put the values. What is V naught square? 100 by 2. What is the value of R? T. What is Z square? We got 3153. To calculate this one, how much you are getting? 5,000 upon 6,000 something. So 0.79 something you will get.
Yes, a 0.79.
Okay. So this is the little bit calculative questions. So this way we can calculate easily. I was trying to get some another way to solve it, but I can't do it by any another way. We have to do calculations. So this was the basic method to do it. We have to put the values given in the question and we can do that. Got it?
Yes, sir.
Was little bit lengthy, but yes. So it was NEET 2018 question. Now do the question. 20, very easy question. Seem to be difficult. So attempt question number 22. Questions are very frequently asked. Are you trying?
Sir, I'm not getting the idea how to solve.
Alright. So according to the question, the given circuit, the reading of voltmeter V1 and V2 are 300. Getting my point? So in the question it is given that V1 and V2 equal to 300. Okay. The reading of the voltmeter V3. So we have to find reading of the voltmeter V3 and ammeter A. We have to find reading of the ammeter. So how to solve it? Any idea? It's a very good question, frequently asked in many. Mamuna, any idea how to solve this question? See, in the class of resonance, we have also discussed. According to the question, what is V1? V1 is the voltage across inductor, right?
Yes, sir.
And V2 is voltage across capacitor. In the question, it is given that V1 equal to V2. It means, and we know that it is series circuit, so we can also write V1 is equal to I into XL and V2 is equal to I into XC. What does it mean? XL equal to XC, right? It means it is the resonance
Resonance.
circuit. Whenever you are getting equal voltage across inductor and capacitor, you can blindly assume that the circuit will be resonance because XL will be equal to XC. So if XL equal to XC, so and we know that inductor and capacitor are in opposite phase. So what happens is their voltages cancels out. Generally in resonance circuit, what happens because of opposite phase of inductor and capacitor, their voltages get cancelled out and all the voltage appears across resistor. So what will happen? The applied 220 volt will appear across the resistor. So the reading of the V3 will be 220. See my point? So D
Yes.
and A cannot be. Now you have to find the current. So in resonance circuit, what is the value of current? We know that I is equal to V by Z. I equal to V by Z. Here we can write V by Z since in resonance voltage and current are in same phase. So here applied voltage is 220 and what is Z? In case of resonance Z equal to R. So 220, what is resistance?
100.
Resistance is 100. So we will get 2.2. The correct answer is what it. This is
Sir,
your
I will be IRMS or I not.
pardon.
So here we're equating I is equal to 220 by R, right?
Yes.
That should we consider I not, like
No,
I
we
not
have
by
to
root
consider
2?
IRMS. Whenever nothing is given, we have to consider RMS. 220 volt is actually RMS value. Getting my point? So if we are taking RMS voltage, we have to take RMS current.
Okay.
Any doubt? So in such questions, this is the only way to do that. Otherwise, if you will go in calculation, you will end up with no result and you have to do calculation and calculation. So you have to be very careful while identifying the given. Whenever you are getting an LCR circuit, it is 80% chances are the circuit will be in resonance. You have to identify. Otherwise, LCR circuit becomes very complicated and very calculated. If you have seen the previous question, that was also LCR circuit, right? That was very calculated. So this is, let us do one more question. So transformer we will discuss in the next class. Question based on it. Let us do a JEE question. To question number 1. Do you know the formula of quality factor? I will give you a hint.
So 1 by R root L by C.
Yes, correct. This is JEE 2020 question. Very easy.
So option A.
We got option A. You applied the formula of this one, right?
Yes, sir.
Quality factor is generally in the range of, let us see, I will calculate it properly. It's 800 to 10,000. D is 10 to 40 into D. Will get it 2 by 100 to 100. Let's do the last question. You take the question number 4 and 2 as homework. Take a screenshot of question number 2nd and 4. Third also. 2nd, 3rd and 4. Third you can this is the Euler circle. Take the 4, leave the question 2nd and 3rd. Take the 4 as homework for the 10. Question number 4. Take the screenshot and click a photo also. Number 4. We will discuss it. We will discuss this. Alright, I am getting this is all for today's class. Have you taken the photo of question number 4?
Yes, sir.
So this is all done for today class. Any doubt till now?
No, sir.